Yeah, dear students, good morning. Already I gave two videos through which we solved one mock test number one. And today I want to discuss about the Tondy formulas. That is the shortcut methods. While we are solving the problems in the exam, either it may be JEE Mains or CET or any objective test exam, we have a very short time to solve each problem. Say 1 minute or 1.5 minutes, but we have to take only 1 minute. For that purpose, we have to use some shortcut methods. Tondy is a person, a mathematician, North Indian. He formed a 200 formulas, shortcut formulas methods. Already I solved in the previous videos some formulas, but now we will discuss about those formulas of Tondy. It is very useful to solve the problem not by using the traditional method. Okay, now try to take it as a problem, please. Okay, now we will go to start number one. See, number one, it is a geometry, two-dimensional geometry. Suppose we are given A, x1, y1, B, x2, y2, and C, x3, y3, D, x4, y4. We are given the vertices of a quadrilateral. Here I am taking the generally x1, y1, x2, y2, these are all variables. But we are given in the problem 1, 2, 5, 7, 10, 11, like that 4 points are given, which are vertices of quadrilateral. Then we are asked whether it is a square, a rhombus, a rectangle, or a parallelogram. For that purpose, you see, the Tondy formula. The Tondy formula is, you see, observe. Suppose it is a quadrilateral. It is a quadrilateral like this. No side is equal to other side. Okay, now we are given x1, y1. It is x2, y2. It is x3, y3, x4, y4. Okay, now here let alpha is equal to slope of AB into slope of AD. We find the slope of AB and the slope of AD. Let that number, if you find the slope of AB means we know y2 minus y1 by x2 minus x1. Similarly, slope of AD is y4 minus y1 by x4 minus x1. A formula is there. Difference of y coordinates by difference of x coordinates. Like that you find. Let that is alpha. Similarly, beta. It is a slope of AC into slope of BD. Slope of AC means like this. Slope of AC and the slope of BD. Here also we find the slope. Very simple. y3 minus y1 by x3 minus x1. And here also y2 minus y4 by x2 minus x4. Like that. And by simplification we get simply alpha and beta. Now you see, if alpha is equal to -1 and beta is also -1, after solving this alpha and beta, if it is minus 1 and minus 1, that implies the quadrilateral ABCD is a square. It is a square. Easily you can understand. Because the slope of AB and the slope of AD, in the case of square, you see, square means the adjacent sides are at right angle. Will you agree? The slope of, say it is M1 and it is M2. Slope of AB into slope of AD. M1 into M2 is minus 1. Similarly, slope of AC into slope of BD also. The diagonals are at right angles. So, by using that concept, if alpha and beta both are equal to minus 1, is a square. Alpha is equal to minus 1, but beta is not equal to minus 1. Then ABCD is a rectangle. Easily you can understand. Rectangle means, of course, adjacent sides are at right angle. AB and AD, their adjacent sides are right angle. But diagonals not be needed having right angle. Okay, na? AC, BD, they are not right angle, not at right angles. If they are at right angle, it becomes as a square. But here it is not 90 degrees. So it is a rectangle. So condition is this one. Alpha is not equal to minus 1, but beta is equal to minus 1. Then ABCD is a rhombus. Why? Because you see the rhombus, in the case of rhombus, you see the adjacent sides are not at right angles. AB, AD are not at right angles. Whereas AC, BD are at right angles. Okay, now the diagonals are at right angles. That is why we are getting beta is equal to minus 1. Again, alpha not equal to minus 1 and beta also not equal to minus 1. Then ABCD is a parallelogram. That means, you see, like this. The adjacent sides are not at right angles and diagonals are also not at right angles. Okay, na? That is it. So, alpha and beta both are not equal to minus 1. It is a parallelogram. Alpha and beta both are equal to minus 1. It is a square. And you make the difference. It is an important concept. Okay, na? Yeah, pass. Okay. Number 2. To say, finding orthocenter. Okay, na? Finding orthocenter. Suppose a triangle is like this. Is A x1 y1, B x2 y2 and C x3 y3. We are given vertices of triangle and we are asked to find the orthocenter. Already we solved in the previous videos the orthocenter. Orthocenter is the point of concurrent of altitudes. This is orthocenter. But we are given only the vertices. How we can find? If we are asked centroid, we can find easily. x1 plus x2 plus x3 by 3. y1 plus y2 plus y3 by 3 is centroid. Okay, it is okay. Whereas orthocenter, circumcenter, in-center, x-center, there are 5 types of centers of triangle. First, orthocenter. In order to find orthocenter, it is difficult to find, that difficult means it taking so much of time. By traditional method, it is taking so much time. So, by Tondy method, you see, by Tondy method, it is easy to solve by using one method. It is x1 of x2 minus x3. Okay, now I will write it as x of x1 minus x2. I am reducing. And y of this y1 minus y2. Okay, now is equal to x3 of x1 minus x2 plus y3 of y1 minus y2. Okay, now here x1, x2 they are numbers. Suppose it is 1 comma 2, it is 3 comma 5, it is 7 comma 8, like that. Yes, you know. For example, I am telling. It is x of 1 minus 3 na, x1 minus x2 plus y of x and y, they are general. It is variable. y1 minus y2, it is 2 minus 5 and x3 is 7. 7 of same 1 minus 3 and y3 means here it is 8 of, it is 2 minus 5. Okay, now? It is minus 2x minus 3y is equal to minus 14. It is minus 24. Okay, now it is minus 28. It is 2x plus 3y. Okay, now? Yeah. Now, how do we solve this? We find this orthocenter means this is a Tondy equation. By using the Tondy formula from the 3 vertices of triangle for which we are trying to find orthocenter. First we find this one. And suppose options are like this. First option is some 7 comma 8, B option something, and C option something, and D option something. Out of these 4 options, which satisfies this equation, that is the orthocenter. In such a manner, we have to solve it. I am giving you an example only, but perfectly we solved one problem. You see, now we are taking one example. It is y-axis, x-axis. Suppose it is A, B and C. It is minus 1 comma 0. It is 1 comma 0 and it is 0 comma 1. Okay, now these are vertices of a triangle. Now it is x1 y1, x2 y2 and x3 y3. Okay, now by using the Tondy formula, x of x1 minus 1 minus 1. Okay, x1 minus x2, that formula. Plus y of 0 minus 0. Okay, y1 minus y2 is equal to x3 of 0 of same minus 1 minus 1 plus y3 1 of 0 minus 0. Okay, yeah. You see, this is minus 2x plus 0 is equal to 0 plus 0. So x is equal to 0. Okay, that is everything. Suppose its option is first option is 0 comma 1. The second option, same problem is there. Second option, we are given 1 comma 0. Third option is minus 1 comma 1, and fourth option is minus 1 comma minus 1. Like this is there. Now which option satisfies this equation. That is the method. By using the Tondy method, we are getting the Tondy equation x is equal to 0. That means x coordinate is 0. Out of these 4 options where x coordinate is 0, only this one. So this is correct. Okay, now, by traditional method, you follow this problem. You try to solve this problem. We get 0, 1 is this is orthocenter. This is orthocenter. How you see it is at right angle. Okay, now? Or by using the traditional method, you find at last we get 0, 1. Okay, now? How can I say this is at right angle? This equation is minus x plus y is equal to 1. This is x plus y is equal to 1. It is x-axis. Both are perpendicular. So it is right angle. In a triangle, the vertex which is at right angle is the orthocenter. Okay, na? Right. That is the thing. Yeah, pass. Okay. Now, the third formula. It is finding circumcenter. Okay, na? Suppose we are given a triangle same with vertices x1, y1, x2, y2 and x3, y3. Yeah. And we need to find the circumcenter. Already we solved this type of problems. Circumcenter means the point of concurrent of perpendicular bisectors. Suppose D and E are the midpoints of AB and AC. The perpendicular bisectors. SD is a perpendicular bisector of side AB and SC is circumcenter bisector of side BC. Similarly, here also like this. Then how can you find? See, here also a Tondy method. See, it is 2x of x1 minus x2, 2y of y1 minus y2 is equal to x1 square plus y1 square minus x2 square minus y2 square. Okay, now? For example, here also just we are giving an example and clearly we solve there. Suppose it is 1, 2, this is some 4, 6 and it is 5, some 7 like this. It is 2x of, it is 1 minus 4 plus 2y of 2 minus 6 and it is 1 square plus 2 square minus 4 square minus 6 square. Okay, now? It is 1 plus 4 minus 16 minus 36. Okay, now? Just we are solving the example. x1 minus x2, 1 minus 4, y1 minus y2, 2 minus 6. Okay, now? And x1 square plus y1 square, x1 square plus y1 square, 1 square plus 2 square, minus x2 square, y2 square, 4 square minus 6 square, that's 6 square. So it is some 52 minus 5, yeah, it is 7, 47. It is minus 47 and it is minus 6x and it is minus 8y. Suppose it is 6x plus 4y, or otherwise you simply leave it. 6x plus 8y minus 47 is equal to 0, like this. Options are there, assume some options are there, like this. Which option satisfies this equation is the circumcenter. Okay, now like that we have to solve it. Now perfectly we take an example. You see, say for finding the orthocenter in the previous second formula I used one triangle. It is minus 1 comma 0 and it is 1 comma 0. It is 0 comma 1. It is a right angle. Actually it is a right angle because it is minus x plus y is equal to 1. It is x plus y is equal to 1. Okay, now don't confuse. This is a triangle. It is a right angle. It is an orthocenter. You know it. Circumcenter is, in a right angle triangle, circumcenter is the midpoint of hypotenuse. For right angle AC or AB. AB is hypotenuse. The midpoint of hypotenuse is itself is a circumcenter. We know it. Here it is horizontal. Okay, now horizontal midpoint of AB. But by using this Tondy method, it is 2x of x1 minus x2 minus 1 minus 1 plus 2y of 0 minus 0 is equal to x1 square 1 plus 0 minus x2 square minus y2 square 0 square. Here also x1 square plus y1 square. Minus 1 square is 1 0 minus 1 0. Yeah, okay. It is 0 cancels. Here it is minus 4x plus it is 0. So x is equal to, here also we are getting a same 0. Okay, now right. You see, for example, options. I am taking options. Number 1, first option is for example 0 comma 0. Second option is minus 1 comma 0. Third option is 1 by 2 comma 0, like this you take. Fourth option is so 1 by 2 comma 1 by 2 as well. Okay, now which option is satisfied? Which option satisfies this equation? This Tondy equation must be satisfied by the any one of the options. You take the second option will not satisfy. Third option 1 by 2 comma 0. Fourth option also not satisfies this equation. Only the first option. Okay, now so this is the method to solve. Just I am for the purpose of to understand this one I am doing. In the example very clearly we can find it. Okay, now in example if this type of question is given, easily by using this traditional method, this Tondy method we can find. Okay, now that is a circumcenter. Okay, that's yeah. The fourth one. Suppose we are asked a problem to find the area of triangle. The area of triangle which is formed by the 3 lines ax plus by plus c is equal to 0 is a line in the side AB. It is Lx plus My plus N is equal to 0. Suppose the side BC is represented in the line given Lx plus My plus N is equal to 0. And the third side AC is represented by Px plus Qy plus R is equal to 0. Like this. Where given the sides of triangle and we are asked to find the area of triangle, not vertices. Then area of triangle ABC is equal to, it is 1 by 2 determinant A, B, C, L, M, N, P, Q, R, and by the first minor A, BLM plus the second minor MN2R plus the last minor ACPR, and all must be in the modulus. Take it as in the modulus again. Okay, now you see, first the coefficients A, B, C, L, M, N, P, 2, R. Okay, now by using those coefficients of all the three lines A, B, C, L, M, N, P, Q, R. Okay, now that is 3 by 3 determinant. By in this determinant, you see A, B, L, M. Next M, N, Q, R. Next A, C, P, R. All addition only. The 3 minus addition, and put it in a modulus. Okay, now this is the area of the triangle formed by the lines which are represented in the sides. Okay, now that is okay. By taking any one example, we can solve it. You do yourself with your own effort. Now I want to go to find the fifth Tondy formula. Just we change the topic. Suppose capital N is equal to an integer. N is capital N is an integer. We assume. Let it be an integer. If the N, this integer can be expressed the product of prime numbers. Say it is 2 power q into 3 power 2 power p into 3 power q into 5 power r into 7 power s, like this. Suppose it is in that manner. We can find the number of divisors. The number of divisors of this capital N is, it is P plus 1 of Q plus 1 of R plus 1 of S plus 1. Okay, now the number of divisors. It is not easily understood. I will explain it by taking one example. Suppose take 324 is a number. Let it be N. This is a capital N. Is an integer, a positive integer. We can write it as 3 into 108. Okay, now right. And again, this can be written as it is 4 into 2 into 7. Will you agree? Yeah. It is 3 into 4 into, this is 3 cube. So it is 3 power 1, 3 cube means 3 power 4 into this 4 is 2 square. So it can be written as 2 square into 3 power 4. This 324 is a number. Okay, now it is an integer, given integer. Whatever it may be, this is a 3-digit number. 5-digit number, 10-digit number, whatever it may be. Any integer can be expressed in the simplest powers of prime numbers. 2, 3, not 4. 2, 3, next 5, 7, next not 8, 9, 10, next 11 only, and then 13, 17, like this it is going. That is the simplest formation in the prime numbers with the powers. Here is, you see, 2 square, 3 power 4. Here 5 is not there. We may say it is 0, but not needed. 5, 7 is not needed. Here only it ends. Okay, now. Then the number of divisors. In this case, we may feel that 2 and 3 are the divisors. No, not only 2 and 3. You see, this 324 can also be written as you see 162 into 2 now. 162 into 2 to 2 is 4, 60 into 32. Yeah. So 162 is also a prime number, not only a divisor, not only 2, 3, again 362. You see, this also can be written as, you see, again we write it as 2 into 8, 1 into 2 now. So it is 81 into 4 now. So 1 is also one factor, one divisor. 4 is also divisor. But by using this method, we can see only the prime numbers only. But in it, it is considered, it is there in this formation. So not only 2 and 3, 4 is also is there, 81 is also is there, 162 is also is there. You see, this is 27 into 3 now, into 4. So 27 is also a divisor. And 3 4 12 is also a divisor. Okay now? Like this, how many divisors, different divisors are included in this number? That is the question. Okay now? Now we take one example. You say, okay now? Or otherwise, we shall here by taking this example. Say, given number is capital N is equal to 324. Then 324 means it is 2 square into 3 power 4. Yeah, okay. 2 square into 3 power 4. Then the number of divisors. We are asked the number of divisors. It is p plus 1 into 2 plus 1. It is 2 power p into 3 power 2. Yeah. So it is 2 plus 1 into 4 plus 1. It is 3 into 5. So it is 15. There are 15 types of divisors. Okay na? Here only I will tell it. One more thing. Note. Number of proper. It's a proper divisor. Proper divisor. Okay na? It's simple. It is a p plus 1 into q plus 1, r plus 1, whatever it may be. Okay na? S plus 1. Okay na? At last to take minus 1. What is the need to subtract minus 1? That is the correct number. What is the need means? Any number to itself is a divisor. For this example, 324 is itself is a divisor to it. The 324 can divide the 324 one time. So it is also a factor. It is also a divisor. So by subtracting that number 1, we can get the proper divisor. Okay na? Okay na? Yeah. Like this, we will solve so many things are there. I will tell it. Thus. Okay. You see, n be an integer, a positive integer, and this can be written as the simplest form 2 power t into 3 power q into 5 power r into 7 power s, like this we take. Then the number of divisors already solved. The number of divisors is equal to p plus 1, q plus 1, r plus 1, s plus 1. Yeah. The number of even divisors. If we are asked even divisors, the number of even divisors. Okay, now it is p of q plus 1 of r plus 1 of s plus 1. Only on p. P plus 1 comes. Suppose 2 power 4, 3 cube, 5 square, 7 pound 1. Like that, if you are given 2 power 4, then there you take only the 4 itself, not p plus 1. Okay, now you reduce 1, 2. Why? Because we are taking 1, 2 total. Then each and every divisor multiplied with 2 means it is a even number. That is the concept. You follow it, and we will solve the example. Okay. Next, number of odd divisors. Odd divisors. You see, it is a total number of divisors minus even number of divisors. Okay na? Is okay na? Total we know it. This is total number of divisors. Subtracting even, we get odd. What do you know? That is. Next, fourth one. You see, it is a sum of, the sum of all divisors. These divisors also called as factors sometimes. In some questions, it is also like given the factors. The number of all factors, the number of even factors, the number of odd factors. Similarly, the sum of all divisors, all factors. Okay, now after finding all divisors, if you add totally, what is that sum? That is the question. Okay, now it is 2 power p plus 1 minus 1 by 2 minus 1. 3 power q plus 1 minus 1 by 3 minus 1 into 5 power r plus 1 minus 1 by 5 minus 1 and 7 power s plus 1 minus 1 by 7 minus 1. Okay, now like that. It is not perfectly ended with 7. If suppose this n is here into 11 power some z is given, 13 power some alpha may be given, 17 power some beta will given. Like this we have to expand it. Okay, now that is the method. By using this one formula we can find the sum of all divisors. The last one, sum of all even divisors or even factors. Suppose it is asked like that. There you use 2 power p minus 1 by 2 minus 1. 3 power 2 plus 1 standing. Minus 1 by 3 minus 1. It is 5 power r plus 1 minus 1 by 5 minus 1. Like this. It is 7 power s plus 1 minus 1 by 7 minus 1. Like this it is going on. Okay, now if we are asked the sum of odd, then total minus even. Say this manner. Okay, now like this you can solve it. Now we will go to one example. You see, one example. It is 25. N is 25. 20. You take like this. 25, 20. This 25, 20 can be written as first 10 into, okay, now it is 10 into, this is 4 into 4, 6, 4 3s. Will you agree? 4 3s, 4 6, 63s. It is 5 into 2 into 4 into 7 into 9. Will you agree? Yeah. This is 5 into 2 into 2 square. This is 4 and it is 7. It is ultimate one. 5 and 7 will not be reduced. And 9 is 3 square. Now totally it is 2 cube, 2 power 1, 2 square. 2 cube into 3 square into 5 power 1 into 7 power 1. So this number, a 4-digit number that is given, n can be written as like this. Okay now by using the number of divisors or factors also, it may be also called as factors. We know the formula p plus 1, that is 3 plus 1, 2 plus 1, 1 plus 1, again 1 plus 1. Okay now? I'm not writing this formula again. Once again, you follow that one, number of divisors, p plus 1, 3 plus 1, this is p, q, this is p, this is q, r, yeah. Okay now? 3 plus 1, 2 plus 1, 1 plus 1, 1 plus 1. This is 4 into 3 into 2 into 2. How much? 12 4s 48. So 48 different types of divisors are there. Once again, I will tell. The 2520 is itself is a divisor, and 1 also divisor to it, that number n. And 10 is also 5, 5 2s, 4, 63, 252. Is it not it? 126 also will come. Like that, how many different types of divisors are there means 48 different types of divisors. Directly the question given like that in the exam. Simply a number will be given. What are the number of divisors? You see here the number of proper, already I do. Proper divisors, suppose asked. We are asked proper divisors. How can you find proper divisors means? It is 48 minus 1 is equal to 47. Will you agree? Why? Only that number excluded. Okay now, so 48 minus 1. Okay now, that is a proper divisor. Now we go to okay, I am erasing this 2 because it is already given. Okay now, next the continuation I am going to solve. The number of even divisors. Number of even divisors means you exclude 2. Where given 25 and 2520 can be written as 2 cube and 3 square into 5 into 7. You take 1 and 2 as common. This is 2 square, 3 square, 5 power 1, 7 power 1. Now P is equal to 2 only. Q is equal to 2. And R is equal to 1. That is also 7. 7 is yes. Okay now. Now the number of divisors means I will write here. The number of divisors, even divisors means it is formula is there. You use that one also. It is P of Q plus 1, R plus 1, S plus 1. Okay now. What is P? Only 2. Okay now. 2 into Q plus 1 is 2 plus 1. R plus 1, 1 plus 1. It is S plus 1 means 1 plus 1. It is 2 into 3 into 2 into 2. How much? It is 24. So there are 24 different even divisors. Okay now? Right. Now, the number of, we need odd divisors. Number of odd divisors means total minus even divisors. We know it. Total is 48. Don't go to proper divisors. 48 minus 24 is again 24. Okay, na? Like this. Okay, na? The last concept. Sum of all divisors asked. Sum of all divisors. It is 2 power p plus 1 minus 1 by 2 minus 1. The formula already is there. Here, first I will write it as the formula. Okay, na? 5 power r plus 1 minus 1 by r minus 1. I mean 5 minus 1, and here it is 7 power s plus 1 minus 1 by 7 minus 1. Now say, what is p there? It is 3. So 2 power 3 plus 1, 4 minus 1 by 1, 2 minus 1. 3 power, what is q? 2 plus 1, 3. 3 cube minus 1 by 3 minus 1 is 2. And 5 power 1 plus 1, 5 square minus 1 by 5 minus 1 is 4. 7 power same. Yes is 1. 1 plus 1 is 7 square minus 1 by 7 minus 1 is 6. Okay. You say it is 2 power 4, 16 minus 1 is 15. And 3 cube, 27 minus 1, 26 by 2 is 13. And 5 square is 25 minus 1 is 24 by 4 is 6. 7 square is 49 minus 48 by 6 is 8. Altogether it is 9360, like that it will come. Okay, Nana? That is the sum of all divisors. Very good question, very good concept. By using this given number 2520, how many types of questions will be raised? Okay, na? Even we may find the sum of all even divisors also. First you find this formula. Here it is 2 power p only for even. For odd, if you are asked total minus even, we get the odd divisor. Okay, na? This is a very good concept for it. Yes, for